So now let's look at some identities. And here they are. And you'll notice on the left-hand side, we have the product. What do we mean by the product? Well, we can see that we have sine alpha multiplied by sine beta. So they're being multiplied together. So this is a product. And the same for these other three over here. And on the right-hand side of these identities, you'll often find a sum or a difference. And these are often called the product to sum identities. So in example 1, we're asked to rewrite cos 5x multiplied by sine 3x as a sum or difference. Now you should notice cos 5x multiplied by sine 3x is a product. Now I'll write alpha as equal to 5x and beta as equal to 3x. So we could read this as cos alpha multiplied by sine beta, and this will help us determine which is the correct product to sum identity we're looking for. And it's this one over here. You can see it takes the same form as what we have over here. So now we can take our original expression and rewrite it using what we have on the right hand side here by replacing the alpha and the beta with the 5x and the 3x to give us the following. Now you can see here within the brackets 5x plus 3x will simplify to give me 8x, and 5x minus 3x will simplify to give me sine 2x. And we can multiply out this bracket by using the distributive property to give us the final simplified form, which you can see is a difference. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following. Now looking at some more identities, we have the following. And you'll notice on the left hand side we either have a sum or a difference. A sum or a difference. And on the right hand side you'll be able to notice we have a product. We can see that because we have 2 multiplied by sine of alpha plus beta all over 2 multiplied by cosine of alpha minus beta over 2. So this is a product, and it's the same for these other 3 identities. So this is often what we call the sum to product identities. So for example 2, we're asked to find the exact value of sine of 5 pi over 12 plus sine of pi over 12. And you'll notice that this is a sum. So what I'll do firstly is replace the 5 pi over 12 with alpha and replace the pi over 12 with beta. So you could read this as sine of alpha plus sine of beta. And this will help us determine the correct sum to product identity, which is here. So now you can see this takes a similar form to what we have over here. So if you take our original expression over here, we'll rewrite it as we have over here by replacing the alpha and the beta with 5 pi over 12 and pi over 12 respectively. And this will give us the following. And you'll notice that this bracket here will simplify to pi over 4. And then this bracket over here will simplify to pi over 6. And then we just need to work out what sine of pi over 4 is and cos of pi over 6 is. And they will be the following. So sine of pi over 4 is root 2 over 2. And cos of pi over 6 is equal to root 3 over 2. And then when we simplify this, it will give us the answer root 6 over 2 as the exact value to the original question. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following. So for example 3, we're asked to solve this equation over here. And you'll notice that the expression we have on the left hand side is a sum. So the first thing I'll do is replace the 4x with alpha and the 2x with beta. So we could read this as cos alpha plus cos beta. And this will help us determine the correct sum to product identity, which is the following. You can see this on the left hand side takes the same form as what we have here. Now all we need to do is replace the original expression with what we have on the right hand side here by replacing the alpha and the beta with 4x and 2x respectively, and then we'll get the following. Now we can simplify what we have in the bracket over here to give us 3x, and we can simplify what we have in the bracket over here to give us the x. Now this is one term here multiplied by another term here, which is equal to 0. These are 2 factors. So what we'll do is we'll look at the first factor, 2 cos 3x, and we'll set this as equal to 0. And we'll solve this for the interval 0 to 2 pi initially. So dividing both sides by 2 will give me cos 3x equals 0. Solving for 3x will give me pi over 2 or 3 pi over 2. And because we want x, we'll divide both of these two answers by 3 to give us pi over 6 or pi over 2. Now recall, we're not actually given an interval here. These are the answers in the interval 0 to 2 pi, so we want a general solution. So now we need to remember for this equation that we have over here, cos 3x, that y equals cos 3x has a period of 3 pi over 2. So the general solution will be pi over 6 plus 3 pi over 2n, pi over 2 plus 3 pi over 2n, where n is an integer. So that's the solution, or one of the solutions we found for this factor over here. So we need to now solve for this factor by setting this equal to 0. So cos x equals 0. And then when we solve for x, we get the values pi over 2 or 3 pi over 2 in the interval 0 to 2 pi. And again, similar to what we had before, there is no interval given here, so we want a general solution. Now we should remember that y equals cos x has a period of 2 pi. So the general solution will be pi over 2 plus 2 pi n and 3 pi over 2 plus 2 pi n, where n is an integer. And these two that we have in boxes, in the red boxes, are the complete solution to this equation over here.